Hi, good morning everyone. Another advent of code. Today we are comparing lists. So here's the problem. We got list paired in this way. So there's always like two new lines between pairs of lists. And now we need to figure out which of those pairs are properly sorted. How do we sort list in this definition? First of all, if we need to lexiconographically filter elements. Sorry, I need to. Yeah. So in this case, we look for first element on the list which differs. Here, the first element on the list is 3. It is lower than 5. Then this list is properly sorted. I mean, this pair is properly sorted. But it may be a case that, let's see second list, the first element is a list, so we need to compare it. It's exactly the same. We go forward, we have lists and we have numbers. So how do we compare lists and numbers? We make this number into a single element list. So this is 2, 3, 4, followed by a single element list 4. First element is lower here. So we see that if we compare lists, we do not compare it in the way that a shorter list is always first. The shorter list is first only if all elements which are on both lists are equal, right? Or some element is lower on the first list. Yeah, and if there is the case, like for example here, we have this case, elements are very much the same, but here we have no more elements on this list. This list is smaller in our ordering, so this is incorrectly sorted. And other case I didn't think about. Numbers are easy to compare, I think. Yeah, and if we compare like necessity, so we have this situation. Yeah, we didn't compare this 4, 4, right? So it's all equal. Then we are going to the next one. On this last example, this one should be first because we are nesting. Everything is okay. Then 0 is lower than 7, so it's improperly sorted. I hope this is clear. As before, let me start my view. As before, I went for parsing. Let my LSP load everything. I probably didn't remove obsolete imports, or maybe I did remove them. It doesn't matter. I went with nom this time, and there's a good reason I went with nom is nesting of our structures. It is possible to write this manually, but there's a problem that if we have this list, it would be kind of natural to just split it using commas. Yeah, we can easily remove brackets. That's like very easy. Then there's a problem if we try to split the list using commas. He would have a problem because we split this, okay, first element, and then this would be our second element and the third element. So to do it properly, we would actually need to have some like character by character parser, and then if we occur the opening bracket, then we start new level of new deepness level of nesting our list, and then on this character we collect the nested vector and close the vector and so on, and it would be not so difficult but kind of itchy, I would say, but nom makes it easy. I created a structure called packet. Packet is top level list here. It's a packet. Or packet single number is also a packet, right? So packet is built from either a number or list of packets. Yeah, so this is packet, this is packet, this is packet, and so on. So this is my top level structure, and then I pass number. So I pass a packet which is a single number, right? Simple enough. My number is one or more digits, which I map through pass with u128, which I picked at the very beginning, and then I map it. So this thing makes me result, right? The type of the type of this pass is result like this, and some magical standard library type, and I want to make it into result packet, right? So I do that by calling the map function, but what's interesting here maybe, or maybe obvious, is I don't pass any closure, I just pass packet number. And because this number is defined as this tuple type with an argument, basically, this kind of tuple variant in enums behaves like constructor functions, basically. So I can pass the packet number variant, and this is a function which takes this thingy, so this u128, and it returns me a packet because it constructs the packet itself. It is exactly the same, like, let's call it p as packet, as this. Would creepy warn me or not? Yeah, creepy warns me, right? That this is the function itself, because number is a function in this context. So this is how I pass my numbers, and then I pass list, and this is how my norm is making things easy for me. So first I create a parser for item. Parser for item is also either pass number, which is a proper item, or pass list may be an item itself, so I can recursively add a parser here. And this is life changer. Then I just do separated list 0, because I can have 0 or more elements on list. And I separate them with tag. Conveniently enough, there are no spaces or any blanks in between. So I just split them this way. Do there. Then there's an item, which is a parser for my item. Then I map this to, because the separated list is a parser giving me some vector, because separated is 0. So I can map this parser with this packet list. So I can wrap this vector with packet list. Exactly the same way I map result parser could be mapped with the return type. And then I just wrap this parser with additional layer with delimited, right? Because my whole thing, my list is always delimited with those things. I can make it delimited, right? With this, and it is basically transparent parser. And then packet list is thing passing the whole thing. So did I do pair? Oh, pair is just a subparser. So first of all, I want my list in pass like this, and this thing is just parser, new line, parser, nothing else. I could do some kind of magic handling, empty space. Doesn't matter. I just have parser, new line, parser. I map it to drop the second one. I could probably do some kind of separated list, but separated list would give me back a vector, but I always want 2. So I just did it this way, and then using this map, I just drop my tuple and unnecessary thing in the middle to create an array of 2 elements. And then it could be also a tuple of 2 elements. I just like array because I can just, do this, and this is twice. And then this is the whole thing is separated list, where every element is separated with 2 new lines, right? So if I would do n here, I could just do 1 n here. It doesn't matter at all. And then in the input function, I just made sure that I didn't screw up something in loading. So I load the whole input. Then I try to parse it with my packet list, right? I decided to unwrap because I want to make it simple today, like really simple. And the thing about puzzles is that you run them once, and if the result is not what you expected, you would correct it, and you actually don't always want proper error handling because it would take you time to implement, which you've seen before. While you just want, there is an error, just tell me what is an error, I want to fix this error and then go on with my puzzle, right? And this is exactly what I do here. I just unwrap on errors, if not ignore them. So I know if something went wrong. Even I even panic if there is something left on input because it means that input is malformed. Here are trim because it turns out when I was testing it, here you see I tested it like naively. It turns out that it was leaving some blank line at the end here. There is a new line, and yeah, I just trim it so there are no new lines on any side, and I just get the meat and I can pass it. So now the problem, and the problem is like very easy, and it is just implementing a comparison of packet. So let's implement a partial odd for packet. We could even implement the odd, but we don't care probably for now. We need to implement odd, but it would be chill. Let's start with adding partial equivalent cubic. I can drive it because this is something which is like natural to implement, but I need to manually implement partial odd probably. Let it implement using mathbus, so I need to implement this function. And how do I do that? I would match on my inputs. Left and order. For now, only for now, you don't leave it in the code because it would ignore your helpful compiler errors. And the easy thing is when we would also use packet everything. So easy case is if both are numbers. I just compare numbers. This is the very easy case. Now there are two kind of simple cases, and I am not doing it efficient right now. I am doing it simply, and maybe later, but not. I may later think about optimizing it, but I don't think I will do it on camera because I'm lazy and because I need to do my work also later. So how do I do that? Maybe do it a bit efficient. So how is this case actually work? So this is like when the list is before my I can split it. If a dot len a is empty. So in this case, my a is actually before I have a list and I have one element. So this is like this. What I wanted to do first is to be very or I will be tricky. Okay, let's leave this to do. Sorry for that. I would add a function fn compare lists being, and it would take left packet, a packet like this. It should return me should comp ordering. How do I do that? Let me check the zip function. I don't want a zip structure, I want this function. Oh, this is what I wanted. Okay, so it goes for... So we can zip them. If zip finds me different, then I return the proper ordering. If not, I just return ordering of their length, right? Because if zip claims those are equal lists, then I probably can then the shorter is before. So let's go l iter dot zip or r dot iter. This way I can just quickly see if there is an error. Okay, it's okay. I was not sure if is convertible easily to iterator, but yeah, it has to because I can iterate it. So it doesn't matter. What do I do now? I would map it using simply, and then I find first. Look how smart is this. This GitHub Copilot. So there's no method cap exists for packet. Yeah, I need to implement the odd. I implemented only partial odd, but I would need to implement odd. Let's do it. And we know that our partial odd will always return something, so I would be very lazy and I would just do self.partial compare order unwrap. Difference between partial odd and odd, because yeah, we have those two traits. So partial odd is partial ordering, which means that I cannot compare all of numbers. So now I have no example of partial ordering in my head. Let's think about that quickly. I mean, I know that floats are not partially orderable, but I don't want to explain why. But let's say we want to compare items based on the graph ordering. So we have like something like this. So this is a graph. Let's imagine this is a graph A, B, C. But then I also have like this, and this is like, we will always have like left to right this arrow. Here is D, right? There's E, and let's say that there is F, and also like this points to F. So we know that A is before B on this graph, right? So we can compare A and B easily. Yeah, A is before A, B is before C, right? That's easy. C is after A. Everything, even you can compare F with all of those. F is after N of those, or N of those. But there is no way to compare B and D on this ordering. This is what we call partial ordering, when not all the items in our ordering can be compared. If they can be, they are either less or equal or whatever, but B and D are not equal. And there's a problem that we cannot use this compare operators on this, because compare operator would return bool, and yeah, it's like B and D. What does it mean? Something is less. And ordering, it is full ordering, I think, or complete ordering, not sure how it's called in English. It's like you can compare any two items with themselves, right? So yeah, it is like this flat structure, and you can always compare them on this axis. And obviously, if something is completely ordered, it is also partially ordered. So this requires this to be implemented, but not the other way. Floats, I mentioned floats are partially ordered, and this is because of existence of none, and also inf. I think no, not true. If inf is the reason, because inf is yeah, inf is problem, because I'm not sure how about this transitivity because of inf, but it doesn't matter. None is the true problem of that, because none is some invalid result, and it's neither lower or higher or of other numbers. And this is the problem because of existence of none. It's very difficult to sort floating numbers, and because they have no complete ordering implemented on in Rust at least. So I explained that, and yeah, lack of this ordering was the problem here, but now we have this solved temporarily. And what we do, we just compare all the items. We look for the first item which is not equal, right? We try to find, and then unwrap all equal, which is completely not true in our case. Unwrap all l.none.comp. This is what you want. So this is how we compare lists, and I thought I would be wrong here doing this nicely. Yeah, I can easily compare this kind of list, but then it's done that way, number and list, and what is greater or what is less, and we can just compare list, no cloning. Why? What happened here? Compare list. First element is our single element list of a number, and the other thing is just my list. Like this. Yeah, it is maybe a bit inefficient because I need to construct a number. But I mean, I will not care about that. Oh, I don't even need to construct this. I can do. Can I do that? So this way, what I am telling it is A is a number, matches a number, and then I can just pass it. False package. Yeah, my package is just clonable. I could go with borrows here, but yeah, I would not cover this clone for now. If I would like to like really boost it, I would try to avoid this cloning, which could be done, but I will not go crazy about that. So this should be all I need. So I have my ordering, easy enough. I have some loading here. Now I need my part one. Part one, it takes input, it returns usize. What was a question here? What was a question here exactly? I need to find indices that are properly sorted. Couple problems here. First, I need enumerate on my input, for sure, because I need indices, and then I need to filter. I don't care about index, but I need to filter those guys with this kind of ordering. I believe we want this because that's a bit of a problem that it was not mentioned how to. It was not mentioned how to handle the equal inputs. I don't know if we have answer. Doesn't matter. Wait. Expected an array size one packet. My input is size of packet pass. That's fine. Then I filter them. I do not count them. I map them so I can drop my value, but I need to add one because they are again the first place in this one. There are one base. I need to apply that, and then I need a sum of those. So yeah, sum of indices would be useful. I hope that should be all I need. 13 is a correct answer for that. Let's download my puzzle input. I don't expect anything to go wrong at this one. It was, I would say, nice but pretty simple task to do. And the second part is now you just need to pull out the packets and write all the description. Once you know this on. Okay. So we have it almost. It's very simple thing to do again. So it is the trick to do a bit of code and to make part 2 simple is to not overthink the first part, because it's very often if you overthink first part and you try to do some tricks instead of just implementing what they want to implement as it is, yeah, you do something which is important in second part. And what was important on the task was to implement comparison, and now we have implemented comparison. So what I need to do here, I just need to go with my input. I flatten the input. Then I change the input with another input, and it is yeah, there are a couple ways to do this easily, nicely. It's packet I need packet list of packet list of packet number of 2, and then I need get list of packet number of 6, I believe. Just type. Right, nice. Then I want to close my vector. I want to, and then I collect it. So let's take a look at what I just wrote. Let's move. Oh, that's my data. I believe it could be done a bit better. I forgot about vectors here. Oh, there's borrows. Yeah, I'll take it as a vector here. I'll just do this and then flatten, but into eta. I mean, I could clone it, but I will never more need the thing here. Consider turning local bond data. Okay. So what I did here, I made my packets into iterator, and flatten makes me that packets are collapsed, and then I chain, and chain is like after this iterator is finished, then go with another iterator and add it at the back, and I just have back here. Yeah, it is not really needed to make it vector. It could be just an array. Yeah, because it is also iterator. So I just append another 2 items, and here I just constructed in place. Another way would be just parse list and do this. Except this guy has one downside. It's slower because it requires the whole parsing, and yeah, it's like kind of very little premature optimization. So I append those 2 things to my iterators, then collect all the iterators. Probably if this would be vector of packets, this could be thing we could improve, is just instead of collecting it here, I mean, I could just match it into whole list of packets at the very beginning, and then only on part 1 I could split it. Doesn't matter. I can flatten it here. If I would go for you know, the fastest solution, then I can figure out which is faster, because it's never obvious. You need to measure it to figure out which is faster. But then I collect it to my data vector. Then I data sort unstable. Yeah. Another thing is that on these puzzles, I often say I would optimize it later. Yeah, those kind of stuff. But there are some stuff it's good to think like to make it your habit. And probably first thing you think about this is just sort. And yeah, you can just sort, but sort unstable is a touch faster sometimes. Because touch unstable doesn't care about ordering items of the same value. If you would have, for example, this array twice somewhere, this normal sort, which is stable sort, would try to preserve the ordering of 2 items, which we don't care about at all. So we can use a touch faster version of this. Yeah, I mean, we are not going for fast solution for this, but good thing to have this as a habit. Because if you are using Rust, then you probably care about performance, and this is something very, very cheap you can do to save a bit of performance. Probably it's not like important, but still. Then I need to locate positions of my sorted elements. Do I have in my vec size? I'm wondering. Is there binary sort? Yeah, there is binary sort. Sorry. So the thing is that we could obviously just search something, but if you search something in the vector or iterator, then there is a problem that it is kind of costly, because I mean costly. You need to go through all the elements. So it's not like this costly, but you need to go through all the elements, while here we know our array is sorted, right? So because we know our array is sorted already, we can do something which is called binary search. So we just try to, if the middle element is proper, no, it's not. So the other half, it's lower or higher. It's lower. So you know, you don't need to even bother with the higher numbers, which is called binary search, and we can use that. If we are 100% sure we are going with sorted data. We are working with sorted data because we just sorted it. And here I did the thing. I extracted the delimiters packets into another variable, so I do not need to construct them again in a second when I would look for them. So let them one position is data except as binary search, what it gives me back. Result of okay, so this is if it's found, this is if it's not found, and you say position, which is what we want. We would just unwrap on that because we know it's there. Data dot binary search. Why binary? What is the interesting thing? What is the error value of binary search? Is usize, so it's not an error. So it's like we don't find it, they didn't find it, and if you want to insert some element to preserve the ordering, then you can insert it here. Yeah, this binary search function is just a way to insert something else. It helps you to insert something into the vector, preserving the ordering. We are looking for the lim1, and we know it's there. The lim2 position, same thing. And then we return what? Multiplication of them. Yep, we just lim. We just give it back. I can do this. I'm doing cron here. Someone is trying to reach me, and it's frustrating because my phone claims it is spam. But doesn't matter. Let's go with that. Then I don't pass borrow, just value. Let's check test input first. Something is wrong, and I know what is wrong immediately. I forgot to offset the indices because my indices are coming here from enumerate function, not from binary search, but it is 0-base indexing, and here we are working with 1-base indexing, which is just to, you know, make you doing mistakes. Unless you're working with some very old version of BASIC, you are probably 0-base indexed. Yeah, so that was easy. I don't think I want to optimize it on Vision. Maybe I would try to play a bit on reducing clones, but yeah, that's all. Thank you, and see ya tomorrow. Bye.